The previous video focused on tables as summaries of data. Tables are good, but data communication can do much better. I want to turn data into visualizations, pictures that express the data. And this is very powerful, since a visualization can be so much more effective. However, it always comes with risk. Visualization is always a choice of how to display data, and, like so many things in this course, that choice is always a judgment call. Every choice of visualization emphasizes something about the data and hides something else. There's no such thing as a neutral visualization. They're always informed by a goal and a purpose. In this video, I'm going to be talking about a data gathered by a bank concerning home loan applications. There were 10,000 cases in this data, and there are three variables. One variable is the current home ownership status of the applicant, whether they already own a home outright, have a mortgage, or rent. Another variable is the application type, whether it's an individual application or joint application. And the final variable is the rating the bank gave to the application, which is a letter from A to G, with A being the safest loan and G being the most risky. Here is a frequency table for the ownership variable, showing the count of all three categories for this variable. And it's not bad to get a sense of the data from this table, but I want to visualize the data. Therefore, I make a bar plot, which you may be very familiar with. In a bar plot, each category is expressed as a vertical or horizontal bar, the length of which is the value of the variable. This is the same data, but now I have a qualitative sense of the relationship between the categories and the variable, a sense that might have been missing from the raw numbers. It's easy to see at a glance the relative sizes of the categories. The previous bar graph was a total count, but I can also do a bar graph with proportions. Here is the same data, but the vertical axis is now proportion instead of count. These proportions have been left as decimals, the count divided by the total, but I could also written of these as 48%, 14%, and 39% if I wish to do so. That was a bar graph for a frequency table. It captured the count or proportion of one of the variables alone. But now let me do some interaction between variables. A contingency table was introduced in the last video to show how variables interact with each other. Here, I want to see how the ownership variable interacts with the application type, individual or joint. Of the 4,789 applications with a mortgage, 3,977 were individuals and 812 were joint applications. Again, the data is here, but seeing what it all means in just the numbers is getting more difficult. With bar plots, I'm going to show you three different ways to express this contingency table. This is a stacked bar plot. These are the same bars as the first bar plot I showed you, but now I have used the second variable, the application type, to color the bars in two colors. In the mortgage bar, the blue is individuals and the pink is joint applications. Likewise for the other two bars. This still shows the ownership variable in the height of the bar, but also gives a good visualization of the breakdown of each bar by application type. It's easy to get a rough sense of how many of each bar are individual or joint applicants. A dodged bar shows the same information, but shows the breakdown side by side instead of in one bar. The total for the mortgage category is now the sum of these two bars, and each subset is its own side-by-side count. This makes the total of each category, mortgage, owner, rent, a little bit less visible, but it makes the comparison in each category between individual and joint much more clear. As I said before, visualization is always about trade-offs, what you want to show, what you are content with making less visible. If the comparison between individuals and joint applicants is the most important, well then this is a good choice. Finally, I can also do something similar with proportions. Here, the total of the mortgage, own, and rent categories is completely gone. All that this plot tries to show is the relative percentages of individual and joint applications inside each ownership category. What is shown is that more mortgages carry the joint application and fewer homeowners do. Again, the choice of plot is determined by what the author of the visualization wishes to display or allows to be hidden. Here, the relative values of the three main categories are entirely hidden. In addition to bar plots, another visualization I imagine you're already familiar with is a pie chart. Pie charts are exclusively for proportions. The pie is always considered as a whole, and each section of the pie is a proportion of the whole. Here is the category data for the ownership variable again, from the first frequency table in this video. This is just one variable. I'm not comparing variables here as I did in the previous 3 slides. This pie chart shows in a nice, clear way how many applicants have a mortgage, how many own a property, and how many rent a property. Pie charts are often great for proportions. They are seen as an intuitive and easy way to read representations of parts of a whole. However, they too can have their weaknesses. I haven't talked about the third variable yet in this data, but here is the data for the loan grades that the bank gave to all its applicants. Again, A is the safest loan to grant, and G is the most risky. This is pretty clear for the early letters, but reading this data for E, F, and G is not pleasant, and even if I were to take away the overlapping percentage text, it's still pretty hard to figure out. Pie charts work well for large percentages, but showing very small slices can often be a problem for this visualization. Again, in addition to knowing terms for these visualization tools, the main theme of this video is that visualizations are also about choice, choosing the right visualizations for clarity and purpose, and realizing that all visualizations necessarily involve trade-offs.